Okay, can you guys hear me at the back? See what happened to my screens. I'm missing one of my screens here. Let's see. How about that? Okay. Good, great. Thanks. Let's see. Okay, let's get going. Hope everybody had a great reading week. But now it's time, you got to pay attention for the next 50 minutes. So this is the second of our lectures on graphics and milestone 2. So if you remember back before reading week, we were talking about graphics APIs, and you don't want to write directly to the hardware like you did in EC241. You want to use a graphics API. And we're using EasyGL, which is a layer that we wrote above GTK. GTK is a very full-featured graphics library. EasyGL is easier to use. You don't have to use GTK at all in this course. You can do everything with EasyGL. But if you wish to, as an extra feature, you can push down and look at what GTK has to offer. Okay, so let's talk about types of graphics functions. Whoops. Let's see what's going on with my... This is not looking too promising. Let's see. Oh, there we go. Okay. So we've got a few kinds of graphics functions. And let's see, let me see if I've got, yeah, okay, there we go. Sorry, I've got a few setup issues here. Okay, all right, that looks better. Well, that's kind of bizarre. Okay, actually, let's flip this back. All right, that looks better. Okay, so we've got a few different kinds of graphics functions. We've got some calls that you're going to use to set up your graphics window, and you're just going to do that once. So you're going to kind of do something pretty similar to what the EasyGL example does. So this is like getting your piece of paper, getting ready to draw. You're going to have some calls that are setting drawing attributes. So that, and you're going to do those many, many times. That's like choosing what kind of pen do you have, how thick is it, what color it is, etc. Then you have drawing primitives calls, and you're going to call these many times as well. So this is where you actually draw lines, arcs, polygons, rectangles, images. Images are like little pictures, bitmapped images that you can paste all over the place. So you have all those primitives. And basically how those things are drawn depends on what attributes you chose. Okay, did you say thick or thin, red or black? And then the last set of graphics API calls are to respond to user input, and those will also get called many times. Okay, so redraw when the window's resized, when the view changes, etc. Graphics is fundamentally, or user interface is fundamentally event-driven. You do things in response to the user input, the events that the user is creating. Okay, so far in your programming career, at least of what you've been taught at U of T, so actually in the center there, can you guys quiet down, please? Okay, so you can quiet down a bit? Thanks. Okay, so far, you have been writing programs where you write code that makes calls to libraries, like the standard library for I/O, for data structures, etc. But you're always in control. And graphics, a lot of the functions of graphics are very similar to that. So you write a program, You want to draw something on the screen, you make a call to this EasyGL library that we wrote. It makes calls to the GTK library that's underneath it, and that makes calls down to the operating system to get it on the screen. So that kind of behaves just like what you're used to. You know, you're in control, you make calls, maybe those calls call other things, but it's all fine. Okay, but there's another set of things happening in interactive graphics. So a person resizes the window or clicks on a button, and that's an event. The user's done something. Okay, and you don't get that event directly. It's actually the low-level, the operating system gets it first. So low-level hardware gets it, the operating system takes it from the low-level hardware, and the operating system feeds it back up through this stack. So it tells GTK that some event has happened, GTK tells EasyGL that something's happened, and eventually we want EasyGL to tell your program that something's happened. Okay, why is that important? Well, the hardware is what knows that an event has happened, but it doesn't know what to do. What actually knows what to do is your program. I mean, it depends what the event is. Some events, EasyGL is actually going to handle itself. It knows what to do. It'll never actually have to do that much with your program. But a lot of events, it doesn't know what to do. So the user basically clicked on some button. EasyGL doesn't know what that button's supposed to do. You made the button. Okay, so it has to try to pass this information to you, or the window's been resized. So you should redraw your graphics, but it doesn't know what you're trying to draw. It doesn't know you're drawing a map of Beijing. So it has to pass information that something has happened back to your program so that you can do something, like redraw the screen. That'll be the most common thing you have to do because the screen's been resized or the person's zoomed in or something. So how do you think that's going to happen? So it's fundamentally backwards. You know, it's not you in control making a function call to say, do this because I want you to print out a string. Basically, this low-level code wants to call you to say you need to do something. You got to redraw the screen now. So how do we make this happen? Any ideas? If you got an idea? I'm going to clear everybody just in case you did this already without meaning to. If you have an idea, press on your mic and I'll turn you on. Somebody's got to have an idea. Okay, so we're going to go to D06. Let me turn off my mic and, okay, you're on the air. Yeah, that's a great answer. So it's perfect, okay? And this is so common, it's given a name, okay? It's called a callback. So you don't know when this is going to happen. The user's going to resize the screen or click on a button, but you do know if that happens, I want you to call this function. So you have to register callbacks. So when you're setting up the graphics, your program, the thing that you write, registers callback functions. So it basically tells EasyGL, if this happens, call this function, okay? And then when those things do, and then it hands off control to EasyGL. And that's done with the EasyGL, most important class in EasyGL is called the application class. It has a method called run. When you call run, it doesn't come back for a long time. You're basically handing control to EasyGL, and EasyGL is going to do whatever it feels like. And when it needs some help from your program, it's going to call one of the callbacks that you already registered, okay? So once you call this, EasyGL is kind of in control. The user resizes a window, clicks on a button, something. Hardware gets that input. EasyGL looks at it, decides what kind of event is this, what kind of callback should I call, and it calls the appropriate callback, which now lets your program do something with it, okay? So let's look at how that works. So this is some setup. The setup code in EasyGL is pretty simple. So if you've worked with other graphics packages, you know that often to get a window on the screen actually takes quite a bit of code. So we tried to minimize that in EasyGL. So in your draw map function, this is a function that's responsible for getting the screen up and running. You're going to have code that looks very similar to this. You're basically going to set some settings for EasyGL. So there's a settings object. You're going to tell it Here's a file that has the layout of the windows. We've already given you one, so you can just use that. You're going to tell it a little bit of information about what's the name of the main window and what's the name of the main drawing area, where you're going to draw your city. And you're just going to use these values. We've set this up for you. You're going to create the window now. And an important thing you have to do is you have to choose a coordinate system. So here we've made a rectangle from 0, 0 to 1100, 1150. So x equals 0, y equals 0, to x equals 1100, y equals 1150. That's going to be our initial coordinate system. We pass that into this function, this add canvas function, and we say that's our initial coordinate system, and we pass it the name of a function. And that's the most important callback. That is the callback that redraws your part of the screen. Now, redraws where is the city. Okay? So you can choose any coordinate system you want. We talked about this in the tutorial just before reading week. You want to choose a coordinate system that is convenient for you, because EasyGL lets you draw on anything you want. And then this draw main canvas, you can use any name you want, but this is your main redrawing function. And you want to make it fast because it's going to get called a lot. Okay, so we've almost got our window set up. We just have one more function. So this EasyGL application object, we call its run method, which is basically we're handing control to it. And we can pass in 4 more callbacks. If we don't want to, we can always set any of these to null pointer, and it means that this won't be called. But there are 4 more callbacks that we can set. Okay, so initial setup is called as soon as the window's created. So it allows you to hook up more things if you want. Act on mouse press is called whenever the mouse button is clicked in your city map, your part of the graphics. Act on mouse move is called whenever the mouse is moved in that part of the window. So you can use that to do tool tips and things like that if you wish. And act on key press is called whenever the keyboard is pressed and the cursor is inside your graphics part of the window. Okay, so to start off with, you may not pass in any of these callbacks. You may just set them all to null pointer to get things going. And in your final program, you may not use all of them, but that's fine. They all exist. Okay, so these are all the names of functions that you write, or null pointer if you just don't want to have that callback do anything. All right, so once you do that, this is what's going to pop up. Well, not this exactly, but this is an example application that you can download off of the Quarkus that we wrote for this course. And it is a good form of documentation. It shows you a lot of the features of the graphics package just by showing you the code, and you can play around with it. So I'm going to fire this up in a minute, and you can look at it. So what I've drawn in a red circle here, this is what I keep calling the main canvas. In our default user interface layout, that's where you draw whatever you want. So you're going to draw a city there. We've also got some buttons that we automatically set up on the right-hand side. So EasyGL sets those up. It monitors those buttons. The person clicks on them. It does the right thing. You notice that they're mostly about, well, this one in the example program we set up, but the rest of these are set up by default by EasyGL. And they're all about moving around, you know, zooming in, zooming out, scrolling left, scrolling right, etc. So basically, zooming and panning is handled for you. You don't really have to do anything to make it work. Okay, and this window is going to be there until you either click this X button to end your program, or you click this proceed button to say, I'm done working with the graphics, go on to the next thing. Okay, so yeah, this is where your redraw function, we called it draw main canvas, and the example code I just showed you draws. And there's another thing down here. There's a little text area where you can put a message. You can change this layout if you want. We give you all the source code. We give you the actual data file that defines this layout. So, you know, some students are offended by the teaching team's graphic design capabilities, and they go, that is a horrible user interface layout. I'm going to change it. That's fine. I don't suggest you do that right away, even if you're offended by it. You don't have to change it, so get some other stuff going first, but you can change it if you like. Okay, so let me quickly demo this. So let's see. I guess before I do that, the main function, well, let me see. I think the best way to do this might be to show you this example first. Okay, so I've loaded up the EasyGL example program that I mentioned exists on Quarkus. So you want to download this and look at it, see how it works. It's probably the most succinct form of documentation you're going to get. So I'm not gonna walk through all of this. One of the things you'll notice is we have these very stylized kind of comments in it. This style of commenting is called Doxygen style commenting. Has anybody ever heard of Doxygen? Okay, so a couple people. So I don't know, B06, maybe I'll turn on your mic. You can tell me, you want to try telling me what Doxygen is? All right, go for it. I put you on the spot.
I think it's just like a super standardized method of writing comments. So one for something there is specify what something does, what parameters define and what returns.
Yeah, that's right. It's a standardized way of writing comments, but there's a reason for it. If you go, basically, tools can parse these comments and turn them into web pages. Okay, so if you go on where the EasyGL Quick Start Guide is, the third link on that page is actually a link to the HTML, the web format comments. So these comments get turned into web pages, and you can go click on them and look at it. So that can be helpful when you're using the API, and that's why the comments look like this. And that's throughout EasyGL, basically. Okay, so I'm going to quickly tell you a bit about this example program. So I'm not going to show you everything because it would take too long. Here I've created an object that is my coordinate system. Okay, so my initial world is I'm choosing my coordinate system. It's a rectangle, and all of the EasyGL classes and functions are in the EasyGL namespace. So just like you had to put std : in front of all the standard library functions, you basically have to put EasyGL in front of all the classes that you're getting from it. Okay, so this is a rectangle defined by EasyGL, and it's just 2 points. It's from 0, 0 to 1100, x equals 1100, y equals 1150. So that is going to define my coordinate system, because here's my main function, and it's basically setting up the window, just like I showed you in on the slides. So there's some kind of boilerplate to set up the windows. And then this is setting up the main drawing area. That's where I say I want my coordinate system to be that rectangle. That's my initial coordinate system. And where I'm saying I want this redraw function. Okay, so this has to be the name of some function that I've written. Otherwise, it's not going to compile. And then I'm going to basically call application, the EasyGL application object that I created, .run to hand control to it. So let's go look at the redraw function, because that's the most interesting one. Okay, so here's my redraw function. I can call it anything I want, but it has to have this function signature. So when you write a callback, the graphics library is going to call you. It needs to call the right kind of function. So this function has to take a pointer to an EasyGL renderer object. Call it anything you want, but it must return void, and it must take this renderer pointer. Okay? Now your redraw function can get really long. So it's a good idea to put nothing in it except helper functions. So all I've got in here are helper functions. So I go look at this draw rectangle example. Basically, you'll see I'm set color to black. I draw some text. I draw some rectangles. Okay, so I'm not going to go through all that, but it just draws a bunch of stuff. Okay. And this is the way you should write your redraw function. If you're drawing entire cities, this could get really long. So just don't write anything in it except calls to helper functions. So I'm going to draw a few different examples here: text, polygons, lines, etc. and a bitmapped image. And now I'm going to build this and run it. Okay, so I'm just building it. So I run it, and this is what it looks like. Okay, so again, this is the documentation of what can you do. So you can draw lines of various thicknesses, different colors. You can draw semi-transparent things. So these are different rectangles, and this green one is partially transparent. You can draw arbitrary polygons. So I'm drawing some drawing some trapezoids and triangles here. And again, some of them are partially transparent. You can draw arcs and filled arcs and ellipses. This draw surface here is actually a little bitmap. Okay, so that's a little picture that we grab from the web, and we can basically paste this anywhere we want on the graphics. And we can draw text at different rotations and so on. As I zoom in, my redraw function just always draws the same stuff, okay? If you look at my redraw function, it doesn't try to figure out if I'm zoomed in or anything. It just always draws. The way the zooming works is I'm drawing in my world coordinate system, which I made from 00 to 1100, 1150. But as I'm zooming in and out, EasyGL is changing how it transforms the drawing calls that I make into pixels. So I'm moving in and out by doing that. Okay, and I can move around and so on. Okay, I added an extra button. Just when I click on it, it just says the button's pressed, so nothing super exciting. When I click, it says down here, the mouse is clicked. And you can do animation if you want to. Okay, so now it's like, when I did that, it basically animated in a line, where it's basically not waiting for me to do anything. It's just drawing on its own. Okay, so let me just, if you look, I'll go back here and show you a couple more things. When I set this up, okay, when I set up application.run, I passed it actually all 4 callbacks. Okay, one for setup. The setup one is what created that extra button, that test button. One for when you press the mouse button, one for when you move the mouse, and one for when you press the keyboard. Okay, so you can see how each of those things are handled by playing around with them. What I want to show you is how many events you get. So if you look down here, you see that, well, let me go to my act on mouse move callback. So if I go there, act on mouse move is just passed a few arguments. The most important are where was the mouse. The mouse was moved at a certain X and Y location. Those are passed in. This is in world coordinates. And it's in whatever coordinate system I want it. So it's my coordinate system. It passes in a couple more things. Passes in the EasyGL application pointer, because I might need that if I want to do some drawing. And it passes in this object, which tells me more about the event. I can look at that object to see which mouse button was pressed, is the shift, or is the mouse button being pressed, is the shift key being held down, etc. But I'm not looking at any of that right now. I'm basically just saying, where is the mouse? Okay, and I've got a few of these callbacks. I've got a different one for when the mouse is pressed. So let's go back here. And you can see, you can get quite a few events, right? As I'm moving around, it's giving me a lot of events. If I click, I got the left mouse button, then I get the right mouse button, and so on. And you can get keyboard events too. Let's see. And that's kind of the main thing about this, graphics. So let me go back and show you a few things about some of these functions. Okay, so the most important routine in here is the screen redrawing routine. And I called that one draw main canvas. I registered that as my callback. The reason you can register functions as callbacks is the way a computer actually calls a function is it just goes to the address where the instructions for that function start. So the way these callbacks are actually registered is the name of the function you give, the compiler just turns it into an address saying there are instructions at this address, go there. So that's how you can call functions that EasyGL didn't even know about. It's just told where to go start executing instructions. So I've hooked up this callback. That's my screen redrawing routine. It's going to get called a lot by EasyGL. And to do much of anything in it, I need this renderer object that's passed into it. I can set the colors. Okay, so I can set them by name. There's some predefined ones like black. I can set them by RGB, so red, green, blue. And there's an optional fourth argument, which is transparency. Okay, so it's called the alpha channel. If I set it to 255, these are all 8-bit numbers, then it's opaque. Or if I don't specify it, it's opaque. If I set it to 0, it's completely transparent, just kind of pointless. And in between, it's semi-transparent. Okay? It is faster to draw opaque lines. It fundamentally takes more work to draw a semi-transparent line because the hardware has to read what is the old value, look at what value you're trying to write, and blend them together. So it's fine to use transparency, but because you're trying to make your program fast, if you're kind of in doubt, do I need to make this transparent or not, then don't, if you kind of don't see a real purpose for it. You can make your lines wider or narrower, so I set the line width, that's in pixels. 0 width lines are special, so if I change this number from 3 to 0, it doesn't really draw a 0 width line, it draws a 1 pixel wide line, so the thinnest line it can draw, and it's allowed, the graphics library is allowed to take a few shortcuts. Like maybe once in a while it gets a pixel a bit wrong. That actually makes it a lot faster. So if you have to draw a lot of lines and it's okay to be thin, make them width 0, because they're about 100 times faster to draw. You can also make dashed lines. All of these attributes, and there are more of them, are sticky, meaning you set them and they affect all the drawing calls that you make after them until you change them. Okay, then we can draw primitives, and there are a bunch of different primitives. So I can draw a line between 2 points, I can fill a rectangle between 2 points, I can make polygons, and so on. Okay, so let me do a quick test. I want to draw a thick, dark blue diagonal line across the middle of the screen over top of my other graphics. So we're going to see if you guys have been paying attention and you know how to do this. Okay, so let me stop this. Okay, so I want to draw a thick, dark blue line over the middle of my graphics and it's diagonal. First of all, where should I put this code? So let me look around here. Yeah, like where should this code go? I have some code for when the mouse moves. I have some setup code. Where should I put it? Any idea? What do you think? But say it really quickly. Got to be fast. Okay, so this is a good answer. So we've got 2 pieces of information here. So I didn't have time to turn on your mic. In the redraw routine, so yeah, that's where all your drawing should go, redraw routine or helper functions. And student has also said draw it last. And I said I wanted to go on top. So drawing order matters. I should draw it last. Okay, so let me go back to my screen redrawing routine. And I got lots of screen redrawing helper functions here. All right, so let me go all the way back up here. And let's see. Okay, so this is my screen redrawing routine. Draw main canvas, that was the callback I registered. I want to go to the very end of it. I should really write a helper function, but I'm in front of a class, I'm in a hurry. If your teammates do this, you should stop them. So, sounds good? That's the right place to write it. What should I write? I want a thick, dark blue line. What do I write? So let's see. I'm going to go to F08. So F08, you're on the air. How do I do this? You got to say it really loud too, and I got to turn on your mic. That's actually hard. Okay, go ahead. So F08, do you know how to do this or not? Or did you accidentally hit the button? You're live. Okay, so tell me what to type. We're pair programming under extreme pressure here, right? So, okay, sure, go ahead. Yeah, so to do hovers, what you use are mouse moves, okay? So that's actually the way people implement hovering. You see where the mouse is, and then if you want to give a tooltip, you basically give a tooltip based on where the mouse is. You don't wait for a click. Does that make sense? So anybody else? I'm going to go on to the next team then. Let's see. E02. I think, let me turn off your mic. E02, you're next. Do you want to take a shot at this? How would you do this? Okay, so the question is, I'm trying to draw a thick blue, dark blue diagonal line across the middle of my graphics. I've found the right spot. It should come at the end of my redraw routine because I want it to be on top of everything else. How do I draw this? So you got to say it really loud. Okay, set color to blue. All right, so everything is part of this renderer. You get helpful tips from your IDE. So it's basically showing me all the functions. Everything that sets an attribute starts with set. So set color. All right, let's do RGB. So red, green, blue. Red should be 0 maybe. Green should be 0. So I'm having trouble hearing you. Can you say it louder? That's true. So I could do blue. I want it to be dark though. So okay, 255 is as bright as it gets. I'm going to make it, I don't know, maybe 110. Okay, so that's my blue color. Okay, what do I do next? Going to use this renderer again. I want a thick line. How do I set that? Right, so I go set line width. Okay, and it's in pixels. What do you think a thick line would be? 10, okay, let's try 10. Okay, so 10 pixels. And now what do I do? Okay, so I need to use draw line. Okay, and basically draw line takes, let me go back and get the tooltip help. All right, so, whoops. And basically it takes 2 points. Let's see if I can get this to show me it's not showing me the exact help I want. So the lower left corner of my coordinate system is 0, 0. So I'm going to try maybe 50, 50. And I'm putting it in these curly brackets because I need to make them points. And there's a constructor that'll take 2 numbers and make a point. So I'm not even declaring them as type point. I could, but just to keep it short, I'm just going to basically construct them right here. I'm going to go to the top right corner. That's somewhere around 1,000, maybe 1050, given the coordinate system I chose. Okay, so let's see if we got it right. So build it, run it. It's not bad. It's dark blue, it's diagonal. Is it thick enough? Do you want it thicker? Let's make it thicker, because that was 10 pixels. So let's try 100. Okay, so we'll build it again. Run it. Okay, so that's a really thick line. Okay? And if I zoom in and zoom out and so on, it does the right thing. Notice that the width of this line doesn't scale. So it's 100 pixels all the time. So that might be something you like. It might be something you don't like. But the width of the line is pixels, so it's not scaling, whereas everything else is kind of moving around. If you didn't like that, you could draw a polygon instead of drawing a thick line, and then everything will scale. Okay, so let's say I want to make it partially transparent. I consider my line a little boring. I want to add some transparency. So what do I do? I can change this very quickly to be semi-transparent. What do I need to do to make it transparent? What do you think? Okay? So there's a fourth parameter here I didn't set. It defaults to opaque. If I set it to, say, 40, this is an 8-bit number. It's 0 is transparent. This is going to be pretty transparent. So let's run it, and we'll see what it looks like. I think I ran it too fast. I hadn't finished building yet. Okay, let's run it, build it again, run it. Okay, so now it looks pretty transparent. And so everything works pretty well. So it wasn't too hard. So drawing things is not too difficult. All right. So other callbacks. So mouse button presses. Again, you have to have the right signature. You can call this anything you want, but it has to take the EasyGL application pointer. It has to take this event structure. You can ignore it if you want, but you have to take a pointer to it. And then it takes an X and a Y coordinate. Those X and Y coordinates are where the person pressed the mouse button, and they're in world coordinates. So they're in the coordinate system that you chose. And if you want to, you can do things like say, okay, which button was it? Okay? Okay, so GTK itself, the lower level graphics library, like most graphics library, it actually works in pixel coordinates. And so in computer graphics, pixels start in the top left and they end in the bottom right. It's a bit of a weird origin, but it's the way they work. It's basically the way all graphic systems work. So those are called screen coordinates. And depending on how big your window is and how high resolution your monitor is, you might have bigger or smaller numbers down here for this coordinate. This can be inconvenient to draw in. We're trying to draw a map, and you don't really want to have code all over your program that's trying to calculate how you convert from the map to pixels. Okay? So that can be kind of a pain, and you don't really want it spread all over your program. So what you're going to do instead is you do most of your drawing, maybe all of your drawing, in what we call world coordinates. So world coordinates are that coordinate system that you chose. So you tell EasyGL what coordinate system you want. And the one that I recommended in the tutorial before reading week is X and Y in meters on the surface of the Earth. Okay? So you convert latitude and longitude to X and Y in meters, and basically you're getting the distance from the equator for Y and the distance from the prime meridian for X. So you'll get pretty big numbers. So these, for example, would be the world limits. These two spots for Toronto. Those might be my world coordinate limits. And you're going to have to compute them for every map, because it's going to be different for different maps. But we talked about how to do that in the tutorial. Now, you may ask for a coordinate system that doesn't have the same aspect ratio as the screen. You don't really know what the aspect ratio of the window is. We don't want to make you figure it out. So you might get some extra part of your world visible. So EasyGL will maintain the aspect ratio of your coordinate system, so it may give you some extra real estate, either vertically or horizontally. Okay? The way panning and zooming works is you're always drawing the same thing, but behind the scenes, when these buttons are pressed by the user, EasyGL is updating something called a transformation matrix. It's how it maps world coordinates to pixels. So you draw the same thing, and here you got most of Toronto on the screen, but after you zoom in some, most of Toronto might be off the screen. And that's fine. You'll just see the part that is inside the window, and you'll zoom in without writing any extra code yourself. So what's going to happen is the coordinates of your world that are visible, like basically the corners that correspond to the screen, are changing as you're panning and zooming. But that's all kind of handled for you. Hopefully that all makes sense. So what does this mean? So it's pretty convenient. It means your screen redrawing function, that draw main canvas, can always draw the whole map. You can draw everything, and you'll just see the right view. So you don't have to write a lot of complicated code in it. Now, a lot of students ask, well, doesn't that take lots of CPU time? And it does take some CPU time for you to be drawing stuff that, you're drawing everything all the time. But it's less than you might think, because EasyGL does what's called pre-clipping. So before it draws anything, it does a quick check to see, is this rectangle or this polygon or this line obviously off the screen? And if it is, it doesn't draw anything. That's a lot faster than trying to draw it. So as you zoom in, you're going to find that your graphics tend to get faster. You can get very clever and say, well, I'm not even going to try to draw stuff that I know is not off screen. So there are ways to speed this up more, but you'll get some natural speed up without doing any of that. Now, there are some times where you kind of don't want things to move around as the person pans and zooms and so on. So let's say, for example, I wanted to have a legend, okay? Maybe I want my legend in the top left, and I don't want my legend to kind of move around. I want it always in the top left of my screen. So for those, we can use basically the other coordinate system. The screen coordinate system, which I showed back here, it's in pixels, okay? And if we want to, you can ask to draw in that. So you basically, it's like another drawing attribute. You basically say, I want to draw in the coordinate system of the screen. So all my drawing calls for the next while are going to be in pixels. That's usually less convenient, but can be helpful for something like this. I want a little logo in the top left or something like that. When I'm done with all the stuff that I don't want to move around, I can set the coordinate system back to world, and now everything that I draw will be back in my usual coordinate system. Does that make sense? I'll take that as yes. Okay, so a major thing you have to do in milestone 2, well, one thing you want to do is just get all the basic stuff going, right? Get everything drawing, let people click on things, so get those most callbacks going, etc. And then what you're going to realize after that is that your map is probably pretty slow. And it might also be really cluttered. So if you're zoomed way in, then there aren't that many things visible on the screen, and you could show fine detail. You could show a lot of little streets and it'll look fine. You could label some of those street names, it's going to look good. But if you zoom out and you draw every detail, it's just going to look like a complete mess, maybe even a black screen, because everything's on top of each other. And it's also going to be slow. So you just drew a huge amount of stuff, most of which is invisible or annoying. So you have to do some level of detail modeling. And we give you some utilities to make this easier. So let's take text. So when you want to draw text, you can choose the font size, among other things, but font size is going to be a major one. Fonts are measured in points, and a point is inexplicably maybe 1/72 of an inch. So this is like pixels. It's something that doesn't scale up or down as you zoom in or out. And the way we draw text is you just basically make a point. So here I made a point at some spot in my world coordinates, and I said I want to draw text centered at that point, and this is the text I want to draw. Okay? But if I'm zoomed way in, or if I'm zoomed way out, for example, it might be that this street that I'm trying to label is actually very small on my screen. Maybe it's only a few pixels. So the name that I just drew over it is actually much bigger than it. So it looks kind of silly. And if I do that for all my streets around it, it looks like a real mess. I just got names all over top of each other. I can't see anything. Okay, so you're basically printing too many names. You're too zoomed out. You can't print so many names. It's a big mess. And it's going to be slow. Like rendering text is actually a lot of work, figuring out all the pixels. So if you draw a huge amount of text, your redraws are going to be slow too. So there are some convenience features in EasyGL. So the draw text function takes, where do you want to draw the text? What is the text? And then it has two more optional parameters. So you don't have to specify them, but you can. And these two optional parameters are bounding parameters. They say if the text is going to be bigger than this in whatever coordinate system you're using, world or screen right now, then don't draw it. Okay? So let's say, for example, that I know that this street is about 200 meters long. I computed that, or I know it, and my coordinate system is in meters. So I can say, I want to draw the name of the street, centered on the street, but only if it fits within a box that is 200 meters high and 200 meters wide. If it doesn't fit in that box, I don't want it to be shown. And now basically, that text is going to naturally disappear when you zoom out. If you zoom way in, 200 meters actually occupies a lot of pixels, and this text will fit in that 200 meter box on screen. If you zoom way out, it won't fit, and text will just start disappearing. But that's much better than just having a really cluttered display. So it's an easy way to turn on and off lots of text. That's not going to be the only level of detail that you want to use. So you can ask questions about the coordinate system. So the most important one is this get visible world. So you specify the initial world coordinates. What is your coordinate system? And usually going to specify it to just cover the whole city. But as a person zooms in and out, what part of your coordinate system is on the screen changes. And this get visible world lets you see that. You get a rectangle in world coordinates that tells you how much of your coordinate system is on screen. And that lets you choose, am I zoomed in or am I zoomed out? You can also, this is less important, but you can ask the same question in pixels, and that just lets you see how big is the window. How many pixels from the top left to the bottom right. And you can basically figure out what is the mapping. So you can say, if I drew a box that is a certain size in world coordinates, how big would that be in pixels? And again, that can let you decide, is it worth drawing this box? And you probably don't want to test every single box. You might just decide, you might check a single building, and if the building fails the test, it looks too small, then you say, I'm not going to draw any little buildings. So this is how you can kind of control what you draw. I'm not going to go through, I had a demo on hit testing, but I don't think I have time for it. I went through one in tutorial anyway. So what I just talked about is drawing and level of detail. You also have to have some interactivity. So you have to be able to highlight an intersection when an end user clicks on it. The way that works is you have to code it in your mouse callback. No graphic system knows what you've drawn. They basically, so when somebody clicks the mouse, EasyGL can't tell you what they clicked on. If it's just some part of your graphics, some part of your city, what you have to do is take that mouse click and see what's near it and interpret it. So you have to put that in your mouse click function. And we talked about that in the tutorial, so you can see that there. Okay. So you are going to wind up writing code in your mouse callbacks that is what's near where the person clicked. And the way you normally do this is you just look through all of the buildings, for example, if you're trying to figure out what building they clicked on, and see, is this point inside any of those buildings? You don't have to be really fast in terms of figuring out what did a person click on, because people can't click that quickly. Redrawing speed is very important. The speed that you handle mouse clicks isn't that important because people just don't click that fast. Okay, so I'm going to skip the demo. Okay, a few more features. You can add your own buttons. Okay, and if you look at the example application for EasyGL on Quarkus, you'll see that it does that. And I went over how to do this in tutorial today too. And you can also write messages in the bottom of the screen here. Okay, creating your own buttons is easy. You just use this create button function. But see today's tutorial to see what's the right way to do this. When you create a button, you attach a callback function to it so that when a person clicks on it, EasyGL will call that function for you and do something useful. You can put a message down here. Instead of just printing to the terminal, you can print messages very easily. It's just one call. Application update message, and you just give it a string. So if you want to just show one string at a time, it's easy. And then you can do more advanced things, but you don't have to do this. So anything that you do where you modify the UI layout, you add additional GTK, what are called widgets, user interface elements, those are all considered extra features. You don't have to do it. GTK is huge, so don't get sucked into it too much, even though it can be fun. But if you want to modify the UI layout, you can add things to it, you can move things around. In the EasyGL Quick Start Guide, we tell you enough to get you started on that. But again, this is optional. You don't have to do it. Okay, so if you find that you like graphics, We're teaching you how to use what are called two-dimensional graphics APIs. Okay, so all 2D points, flat basically, for both the user interface and for visualization. If you like graphics, and graphics are pretty fun, you want to know, well, how do these renderers work? Tell me more about these transformations. And I want to know how 3D works, which is more complicated still. There's a fourth-year course in computer science that talks about how do we go from 3D objects to pixels, which is pretty interesting. And then in fourth-year electrical computer engineering, there's a software engineering course, which isn't about graphics, but usually software projects have a graphical component, so you get more experience in developing user interfaces there. Okay, so that's it. I'll be up here if you have any questions. Last bit of advice. For milestone 2, it's relatively open-ended. Don't leave it to the last minute, and don't try the most complicated things you can think of. Get something simple working first. Sure.
I've just a very quick question. So
I'm just going to stop the recording. Just give me 1 second.